Assalamualaikum and a very good day. I bid to our lecturer, Dr. Nur Rashidah binti Abdul Rahman, and my fellow friends. So today our group, which is group 5, will be presenting about steel truss design of a stadium. So let's start. My name is Aminazila binti Ahmad Tazli and I will proceed with introduction. The Enclave Stadium, located in Georgetown, Penang, is a multi-use stadium with 5,000 seats. It was opened in 2020 and is connected to Peninsular Malaysia via Penang International Airport, Penang Bridge and Second Penang Bridge. Keystone Construction provided building expertise for the project, addressing challenges like local municipality approval, drainage and lighting. So as shown in the slide, firstly is the 3D view of the stadium and the bottom one is the layout plan of the stadium. For design concept, the stadium design concept focuses on safety features, material quality and structural systems. Precast concrete is used for beams, columns and slabs, while trusses are used for tension and compression without bending moments. Isolation trusses have bolted connections for secure connections. The roof structure consists of unit structures along the grandstands with PVC membranes, tile roofs and metal decks being primary roofing materials. Steel structures are used for roof structures with cantilever trusses for strength.
Hi, I am Astra and I will continue for the design concept part. The design concept of our stadium are: first, we concern about the high safety features and the good structural arrangements. Okay, this is to avoid any accident happens and to make sure the cost of the project is under budget. Okay, the second is we will list out the type of raw material such as type of roofs, finishes and service and others to calculate the total loads of the trusses by knowing the total permanent and total variable load. The criteria of the design is important to know the value and the applications of the truss. Hence, the study will use I-section truss. Next, I will move to erections methodology. The rationale for this stadium is: first, choose the suitable type of foundations based on condition of the soil. After that, prepare a machineries such as crane checking to insert the lift and place the component of the trusses. Next, checking the column base and alignment adjustment to avoid any failure. And lastly, choose a suitable of the connections for the roof truss such as bolted, welded or combinations. Next, the types of truss used is Warren truss. This is the standard type of the truss that consists several elements which are pressing members, purlins, top and bottom cords, and web. The steel hollow sections will be chosen for the type of the trusses member. This is because steel hollow section provide great strength, lightweight materials, and easy to install.
Assalamualaikum, my name is Siti Atikah binti Muhammad Zain and I will continue for the part action on the steel truss. The action on the steel truss will be determined by its intended function or use. Each application poses unique challenges and the truss design must be accommodate this specific requirement. In addition to this consideration, it is important to note that the truss structure may be specifically designed to support three types of load, which is dead load (GK), imposed load (QK) and wind load (WK). Okay, I will move to the loading assumption for this project. For the permanent load, all dead loads provided to the steel truss, including the truss total weight and any additional steel element, are considered permanent action. The permanent activity of a roof truss will include the load from the roof cladding, the self-weight of the steel elements, and apply loads from finishes. So this table shows the values for permanent load according to the British standard. Okay, for the variable action, it's refer to the loads that not constant and change in magnitude during the life of the steel truss structure. This action can have a significant impact on the design and performance of the truss. The magnitude and distribution of this load can be vary depending on the specific application and usage of the structure. So this table shows the imposed load that was used in this project according to Malaysia standard. for the wind action, there are two types of wind loads, such as lateral wind loads, which can impact the foundation, and uplift wind loads, which affect the roof and horizontal structure. So this table shows the value of the wind uplift and downlift based on the Eurocode 1 Part 1.4.
Assalamualaikum warahmatullahi wabarakatuh. I am Nurmizatul Anisa Johami. My metric number is DF200109. For my part, first I will explain the determinations of our design load, which is first by determine our load cases. For our truss design, we have 5 load cases using the equation 6.10. As shown in the picture, the critical design load that we get is 2.22 kilonewton per meter square. Next is the determinations of point load at trusses nodes. As consider the area, we get 3 types of point load with the different value, which is 4.44 kilonewton, 6.66 kilonewton, and 7.76 kilonewton for all the members at the upper chord. Next is the determinations of internal forces in member for compression and tension. In these design trusses, we use inspection method to determine this value. Before that, we need to find the reaction at both support. By using the equilibrium equation, we get the reaction at both pin support is 117.66 kilonewton. After that, by using the inspection method, we get all the internal forces in the members for tension and compression. As shown in the picture, the value with the yellow highlighted is indicate the compression members, and the value in the blue highlighted indicate the tension members. By all the values of the internal force in members of our truss design, we took 5 selected critical members for each tension and compression members respectively. As shown in the picture, in the circle shape, that is the values of 5 most critical member for the tension and compression that been selected to design the steel and also the connection. Next, this is the comparison of internal forces between our manual calculation and State Pro. By using this both method, we get the value is identical as shown in the table for 5 critical member that we selected. Lastly, after doing all the calculation for the design resistance, in compression and tension, buckling resistance, and also the connection design for bolt and welded, we get the size and property that we need to use in these steel members and connections of truss design in order to withstand the load of our design load that been calculated before. So, as shown in the table, for our members of truss, we use the size of steel 200 by 100 by 15 UKA, and it is unequal angle. For connection, for bolt, we use the size 18mm with the grade 4.6, and the spacing between the bolt is 13mm, and there are 10 bolts that we use in the connection. And for the connection for welded, we use 6mm fillet weld. It should be noted that for our connection, it is eccentric 90 degree to plane of connection, and we use the header plate connection in order to connect the truss and also the column.
To summarize this project, the truss design was calculated using clause 6.4.3 of EN 1990, focusing on combination of actions. The most critical design load was 17.76 kN applied externally to 12 nodes and supported by pin support. Analysis showed that the most critical members in compression and tension were 858.98 kN in chord II and 284.16 kN in chord GH. The truss connection used bolts and welded connections with 117.66 kN applied to the connection. Steel size were chosen considering safety factors and construction company budget. Angle sections were used and high strength steels were used. Fillet welds were chosen for the most cost effectiveness. The steel grade of grade 2075 was chosen for its economical and safety conscious design.
Assalamualaikum warahmatullahi wabarakatuh. I am Nur Atika. I will continue for the conclusion. There are some recommendations for the enhanced truss design performance. Number 1 is truss member designs. We choose a slightly larger size for compression members to ensure the buckling resistance that remain within the specific limits. to ensure the buckling design is lower or equal to 1.0. This is considered using a slightly larger steel added to account for the aspected critical that may exceed the safety factor. Number 2 is a connection methods. We prefer bolted connection over welded connections because bolted connections offer simplicity of disassembly and maintenance, that is for field installation, place feasibility, material compatibility, stress, concentration reduction, and cost and time efficiency. Bolted connection allow for easy component that removal and reassembly, making them suitable for maintenance, repair, and alteration. They provide flexibility and adjustability to accommodate small difference in dimension or alignment. The bolted connection also can join different materials, that reducing the stress concentration and improving joint strength. Following this, consideration for bolted connections. Bolted connections are often more cost-effective and time-efficient compared to welding. They require a less experience level, especially equipment, additional stage like preheating and post-weld treatments. The choice between bolted and welded connection depends on specific criteria such as complications, lab requirement, structural integrity, design consideration, and industry norms. Then, engineering experts should carefully evaluate this factor before deciding on the appropriate connection methods. In conclusion, by implementing this recommendation, the performance of truss designs can be enhanced and ensuring the safety and optimizing the economic value in the design process. Thank you.